is prime factors. The prime factors of a number are the factors of the number which are not divisible by any other number except themselves and 1. For example, the prime factors of 30 are 2, 3, and 5. Because out of all the factors of 30, 1, 2, 3, 5, 6, 10, 15, 30, it is only 2, 3, and 5 that are divisible by. It is only 3 that are divisible by any other number except themselves and 1. Let's write out the factors of 24. Let's say we have 24. What are the factors of 24? Let's say we have 24 factors of 24. The factors of 24 start by 1. 1 can divide 24. 2, 3, 4, 6, 8, 12, and 24. So all this number can divide 24. So these are now the factors of 24. But let's now write out the prime factors of 24. You have to, and we are able to define what do you understand by prime factors. Prime factors are the numbers that, you say the prime factors of a number are the factors of number which are not divisible by any other number except themselves and 1. So if you're able to see from here, 2, 3, something can divide 4, a number can divide 6, 8, 12, and 24. So the prime factor of 24 are 2 and 3. So these are the prime factors of 24. So we can now have a meaningful thing is that the product of the prime factors, maybe we still want to get the 24. We now want to get a product of the 24. So we call it, this is a prime factor of 24. So now we want to have the product. You know that 24 can be written as 3 times 8 or 8 times 3. But recall that 8 is not a prime factor. So if you want to write the product of the prime factor, you said 2 times 2 times 2 times 3. So this is the product of the prime factor. We have 2 raised to power 3 times 3. That's all. So this is just the product of the prime factor. Now, I want to have another example that relates about the factors of numbers. So let's find the factors of we want to find the factor of 22. The factor of 22 are 1, 2, 11, and 22. This is a factors of 22. Now, we want this 22. We now want to write its prime factor out. So if we are to write out the prime factor out, so we say the prime factors of 22 are 2 and 11. So the product of the prime factors of 11, we have 3 terms. We firstly write the factors. The next we write the products, the prime factors. So the next one we now write the product of the prime factors. These are 3 things that you need. Product of the prime factor. So for 22, we give you 2 times 11. So these 2 numbers that they are multiplying themselves, they were prime factors. So of 22. So which means that they can only divide themselves and 1. So that's why we call it a prime factor. So we are able to find the factors of 22, the prime factors of 22s, and the product of prime factors of 22. Let's have another number like 50. Like, let's say like 50. What are the factors of 50? Factors of 50 are 1 can divide 50, 2 can divide 5, 10, 25, and 50. So these are the factors of 50. So we now need the prime factors of 50. The prime factors of 50. So before I write it, I believe if you are following me, you must have able to know the prime factor. You see, we don't count 1 as a prime factor. Let's start from 2. It is only 2 and 1 can divide themselves. So 2 is among. Let's find another number. It is only 5. Let's check about 10. Something can divide 10. Something can divide 25 and 50. So it means it is 2 and 5. So if it is 2 and 5, they are the prime factor. So the product of prime factors of 50, we give you the 50. You can only select 2 and 5, meaning that 2 times 5 times 5. So meaning that it is 2 times 5 squared. So this is the product of the prime factor. So for 50, we select 3 things. We firstly find the factors. We find the product of the prime factors, and we find the product of we find the factors of the prime factors of 50. Later, we now find the product of the prime factor. So let's try to do another number so you can get it clearly. We need to understand it better in case of having questions. So it's very easy for you to answer the question. Let's have another number like 63. So what are the factors of 63? Factors of 63. So the factors of 63 are 1, 3, 7, 9, 21, 63. So these are the factors. So these are the factors of 1 can divide 63, 3 can divide 63, 7 can divide 63, 9, 21. These are the number that can divide 63. So from this number, we are now going to remove out the prime factors. The prime factors are from here, you don't need to waste much of our time. From 3 to 9, something can divide them. But 3 and 7, nothing can divide 3 and 7 except 1. So, and we don't select 1 as the prime factors. So, therefore, it is 3 and 7. I believe most important thing is how to identify the prime factors out first. If you're able to identify the prime factor, and ability to identify the prime factor determine how you understand the definitions of the prime factors. So therefore, since we have been able to identify the prime factor to the products of the prime factors of 63 is now. So we now want to bring out the product for you to get 63. Remember, 63 is 9 times 7. So instead of you writing 9, you said 3 times 3 times 7. So if it is 3 times 3 times 7, we now give you 3 squared times 7. So in any question given to you, this is the product of its prime factors. So let's find the factors of another lax number in this format. So let's find the factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42. So these are the ordinary factors. So let's now bring out the prime factor. The prime factor will now be, so let's start from able to see. You discover that 2, 3, and 7. Why? These are the only number that it is only 1 that can divide them. Nothing else than that. It is only 1 that can divide them and themselves. So 2, 3, and 7. The remaining number 2, 3, 7. So these are the 3 numbers. So in multiplying them, we have 2 times 3 times 7. It's equal to 42. So these are the prime products of the number. So for at some extent, we were given a little numbers that we cannot deduce the products, and a question saying that express as a product of its prime factor in index form. So before you can able to get it in index form, you have to tabulate. There's something. So we have write 100 in prime factors in index form. Before you do that, writing a prime factor in index form, let's have a table like this. Let's have another table. So now we have 100, we have 2. 2 divided by 100, we have 50. 2 divided by 50, we have 25. 5 in 25, we have 5 and 5. So this will give you the this tabulation form will give you exact the prime factor. So for 100 will now be 2 times 2 times 5 times 5. So we have 2 square times 5 square. So this is the product of the prime factor. So another tabulating form, let's have another number like 116. Let's have another value. Let's have another value like so. It said like 116. So you write a 116. Let's put 2 here. 2 divided by 116 will give us 58. 2 divided by 58, we have 29. 29, nothing can divide 29 except 29. We have 1. So, meaning that 116 will be 2 times 2 times 29, which will be 2 square times 29. So, this is the product of the prime number. So, for getting factors, that is why I use the tabulation form. So, before we proceed to another subtopic, for what you have been doing since, I would like to evaluate you. So, and these evaluations ask me, this is what we let me to know that you are watching this video. Once again, for you to have an opportunity for more video, subscribe to this channel and put on your notification on. So anytime I'm releasing a video, you're able to see, in case the video does not share to your places or the other. So it will be notifying you that I've able to release another video. So let's have a class work. So let's have a class work. Write all factors. Write all factors of these numbers. Of these numbers. You write out all the factors. The number is 16, 116, 2, 36, 3, 72, 4, 56, the 5, 53, the 6, 39. So now the prime, all this we have to write out the factor for this. Now, so the second one is express number 2. Express 60 as a product of its prime factor. Prime factors using index notation. So you use index notation. So now do this. Show that 61 is a prime number. Show that 61 is a prime number. So don't forget to do revision in these our areas, the prime factors, the meaning of prime factors and all that. So we are able to do that. So now you do this as classwork. That is all. So now we now go to the another subtopic. Square roots of perfect squares by factorization method. The square of a number is that number multiplying by itself, meaning that when a number multiplies itself, for example, the square of 7 is 7 times 7. That means the square of 7 means 7 times 7. Now give us 49. The square of 5 will be, the meaning is 5 times 5. So if anybody say square of 5, what it's just trying to say is 5 times 5. So if the statement does not say that square of 5, the statement just bring a numerical value like 5 times 5. What means is square of 5. So any moment you see something like a value like 5, a numerical value written in forms of 5 times 5, what it means is square of 5, which is 25. And square of 15 is 15 times 15, which is 225. Note that we can turn each of the above statements the other way around. For example, the square root of 25 is 5, etc. Symbolically, we have root 25 is 5, root 49 is equal to 7, root 225 is equal to 15. So what I just precisely here is that what we're able to have squared already, like of 7 times 7, 5 times 5, can also be turned around to call it a square root. What we explain here, what we firstly explain here is a square. So a square can also give us a square root. So we have what's called a perfect square, a square, and a square root. So the analysis that we give out here, it is square. So the second analysis here, it is square root, and we are using the same number. So therefore, the square root of 49 is 7, and also the square root of 225 is 15. Meaning that, so this symbol means square root. So I'm able to explain what we understand by square and the square root. So we should note that root a square is root a times root. Is any moment you observe something like root of the same number multiplying the same value, the answer is the same value. So therefore, it means that the root a square give us a. So we were given a question like you have to find root 144. So the first thing you do, as we have able to explain before, is to find the factors of 144. Let's do the factors in let's try to find the factors of 144. So now let's have the factors of 144. 144, let's say 2. 2 in 144, we have 72. 2 in 72, we have 36. 2 in 36, we have 18. 2 in 18, we have 9. 2 in 9, we have 3. 3 in 3, we have 1. So now, the factors of 144, the factors of it is 2 times 2 times 2 times 2 times 2. We're able to count 1, 2, 3, 4, 5. we can able to see 5 of, sorry, this is 4, this is 3, so this is 3, so we count 4 of 2 and 2 of 3. So let's rewrite it again to say the factors of 144 will be 2 times 2 times 2 times 2 times 3 times 3. So let's now rewrite to have, so the real question says that square root of 144, which is root 2 times 2 times 2 times 2 times 3 times 3. So now you see that every of these value occur to 2 times. This one occur 2 times, this one occur 2 times, this one occur 2 times. So I give a different symbol. So let's select 1 2 times 2 times 3. So the value is down 2 times 2 times 3. So which will give us 12. So meaning that the square root of 144 is equal to 12. So in finding the square root of a given number, most important thing to know is you firstly find the factors of that number. So getting the factors of that number will surely help you to find the square roots and the square of the number. So having the square root and the square of the number really have much meaning. So let's have another reasonable example that can give us another insinuations about. So we have, let's find the square root of root 121. This one you don't need to waste much of your time. The factors of 121 is 11 times 11, so which really common. So you now say that root 121 will be written as root 11 times 11. You now rewrite to be root 11 times root 11. So you select 1, which is equal to 11. So that is all. So the same thing about root 25 is the same thing as 5 times 5. You will select only one of the 5. And so now, we now want to have a little way of a number, a little way of having a very big number that we need to understand the value very well. So now, let's have a little arithmetic forms of square root. Somebody says that add roots 144 and root 16 together. You have to add these two numbers together. So we have, and the factors of 144 we have able to do it before, but let's do a quick revision. 2 times 2 times 2 times 2 times 3 times 3. So the root 144 will now be, you write again 2 times 2 times 2 times 2 times 3 times 3. So we select 1, making 2 times 2 times 3. So which is equal to 12. So now we have another one is 16. The first thing you do, you find out the factors. 2 times 2 times 2 times 2. So this is 16. So the 16 now, so the square root of 16, the square root of 16 will be, we have root 2 times 2 times 2 times 2. So which we select 1 2 times 2, which is equal to 4. So That is all. So the square root of, so, but we are to add them together. So root 144 plus root 16 will now be 12 plus 4, which will give you 16. So that is all. So we call this one a simple arithmetics in using the perfect squares and the square root. So we still have to go. For example, we have a big number. So this is why we need the factors to implement. So evaluate. Maybe a question say that evaluate roots 107 584. Don't ever bring any fears to this. What most important thing to do is let's have a little division form. Let's have a division. So now we have a 107. No, let me put it in this form. So let's have 107,584. So let's start with 3. It is 3 that can go. 3 in 9, remain 1. 3 in 15. This is 3 in 10. We have 9 to remain 1 in 16. We have, so the 3 times 3 will give you 9. So let's minus 9 from the value. So it remains 175. This is 175. So what can it divide 175? Easily. I can give all the values. 62 can go. If 62 goes, we have 2. 2 times 62, we have 124. In 124, let's subtract it from the bigger value. This 2 in 7. If we have 2 in 7, we have 5. 4 in 1, we have 184. So another value that can go here, it is in 8 ways. So we have 6, 4, 8. If it goes here in 8 ways, we have, after you multiply with 8, we also have the same value. It will go in 8 ways directly without any stress. 5184. This will give you. So, meaning that the square root of this number, the roots 107,584, will be equal to 328. The reason why this method is not really preferable to use, it's highly a little bit complex. So that is why, but I just have to do it as part of the example. Maybe you were taught in the school. So the best method is to find the factors of any given number to use. So you multiply and you select. So no matter how big the number it is, find out the factor. So of it, 1, find the square roots of the following numbers. The square root of the following numbers. So number 1 is this. We have 169, 2, 400, 3, 2025, 4, 8100, 57744, 6, 2916. So find the square root. So I also want to the second evaluation is simplify roots 121 times root 25. The third one, you submit this to the comment sections of the YouTube. We have a root 9/4 plus root 25/49. So that is the clerk's work for this section. So the quantitative reasonings on prime factors of numbers, perfect square, and square root. Let's see our number here. This is figure 1, figure 2, figure 3. These three figures, they want you to reason how does the square root comes out of these figures. In figure 1, you observe that I will write it out to make it easy and written as you are writing your notes. But let's study this figure 1 now. From figure 1, you see that 4 times 12 gives us 36. By the time you find the square root of by the time you find the square root of 36, which gives us 6, by the time you multiply it by 2, it gives us 12. This one, 12 times 4 gives us 48. So let me give you a better analysis. From 1, the square root of 36 gives us 6. Therefore, 6 times 2 will give us 12. Where do you get the 2? Is a question that you must reason out. That's what we call it quantitative reasoning. This one is finding the square root of 36, find the square root of 4. So, meaning that when you get the square root of 36, you multiply with the square root of 4, you will get. So, that is the reason I don't write the meaning of the 2 before. So, now, mean the root 4 give us 2. So, 6 times 2 will give us 12. So, that is just. So, the square root of 36 is 6. The square root of 4 is 2. So, meaning that 2 times 6 give us 12. So, let's find the same applicable to figure 2. From figure 2. So, let's see what is there. We have root 9 and root 25 will determine our answer. The square root of 9 give us 3. Square root of the second one is 25. Square root of 25 give us 5. So, therefore, it will be 3 times 5 give us 15. Please, let's reason it better. You see the shape now. That the square root of 3. So the square root of 9 is 3 and the square root of 25 is 5. So 3 times 5 give us 15. So we are just trying to bring out the applications. We want you to reason how we apply the square root in quantitative reasonings and on prime factors. So that is for the from figure 3, let's find the square root of 181, square root of 100, square root of 81. This one will give you 10, this one will give you 9. So therefore, it will be 10 times 9. Let's see. 10 times 9 will give us 90. So which is 90. So this is exactly how it works. So in quantitative reasonings, we'll be able to explain the forms that the square root of this and this multiplied to give us 12, square root of this and this give us this, and square root of 181 give us this. We use the knowledge of the perfect scale because quantitative reasonings, it is in every topic in maths. We can use every topic in maths to bring out the quantitative reasoning question. So with this logic, I will want you to help me to practice a question that reason to the So this is a question now. In figure 1, you have to find this place. From what we are able to explain in figure 2, so I'll give you time to write now. So write it out, and you write your answer in comment sections in YouTube. So this is, you have to find this area. As I've said earlier, you have to apply this exactly. We use this one to bring out the value. So that is, there's a video that you search that talks about quantitative reasonings, how we reason fast. So we use the third one too to find this area. So let's have another meaningful example at this junction. Let's study this quantitative reasonings. How does it work to what we have been discussing from the beginning? So let's study figure 1. From 1, let's study it better. What you observe from that place is we have 17 minus something. This is 17. You will subtract this. When you subtract this from this, to give us 9. And 9, it is what we call 3 square. So now, 17 minus 8. Minus 8 give us 9. And 9 is 3 times 3. And 3 times 3 is 3 square. So, this is just how it looks like. So, from figure 2, let's reason what is in figure 2. You said 27 minus 2. It will give us something. Let's say it. 27 minus 2 give us 25. Let's see. 27 plus 2 minus 2 give us 25. But recall, it is the 25 that brings 5 times 5, which can be written as 5 square. So, all these things are what you just, from figure 3, what you see there is 17 minus 1. 17 minus 1 will give us 16. And 16 is something, it is 4 times 4. And 4 times 4 is 4 square. So it means we obey all the laws from the diagram of the quantitative reasoning. So I will want you to have a little reasonings questions, but before doing that, I want you to study it very well, because a quantitative reasoning form, especially in the form whereby we don't even reason about. So you just have to think deeply. But today's topic is that we're in a prime factor. So we are trying to do the quantitative reasonings in the prime factors ways. So this is just it. So I want you to reason about this very well. So, and how it goes. This is the answers. So this is classwork now. But before the classwork, we have sample. The sample is the first line. This is the sample. These are the sample. We call it sample. Yeah, so these are the sample. So now, from the sample, you see, we have 100, middle 17, 49. Another sample, we have figure 1 for sample. 1, 2. Yeah, good. So we have the first sample, the second sample. So I want you to reason now for this class work to reason about the samples. So it is from the sample you're able to discover what you're going to do for 1, 2, 3. Let me label the 1, 2, 3, 4. So you submit every of this answer to the comment sections in the YouTube. So these are the things that will make you to know that you are gaining from these lectures. And also, if you see that everything you are gaining from this channel is meaningful to you, try to share this video to those that you believe it needs. They really need these explanations in academic sections, and also subscribe to the channel. You subscribe to this channel, you turn on your notification on. So anytime we are releasing video, you're able to see it, and share it to the people that you need throughout the whole world, that we need to gain more about our brain, about our level of reasonings. So you send it to them and able to subscribe. So that the answer for this, you send it to the comment section in YouTube. So thanks for watching this lecture this morning. Thanks.